Nina, great to see you. How are you doing?
I'm doing just fine. Intro to the intro.
Yeah, intro to the intro. I'm so excited to go through the book. I thought I'd just go through some of the subheadings. Maybe we could touch on some of those points, maybe expand on some things and talk about some philosophical implications, things like that. Your book, it does an amazing job at taking these complex ideas and then giving context for understanding them. So, it really showed me why ultimately why sound is something in our, our relationship to sound is something to be celebrated. So it really felt like a celebration.
Yeah, my hope with the book is that no matter how much or how little you know about the topic, that you'll get something out of it. So I have students who have had a lot of background in acoustics, for example, and they said, this stuff really isn't new, but it was really helpful to have it kind of synthesized and to have it was almost, a review with some context that they hadn't had before. And then, there are other people who are hearing it for the first time, which is fine too.
Yeah, I really felt that that grounding was so powerful. I remember, learning about sound in biology class or something like that, and there was never that connection to, oh, what is my experience with that thing that's happened with that physical wave. So your first subheading is sound is underrecognized and hearing is underappreciated. And there's this great quote, I think, from Helen Keller that blindness disconnects us from things, but deafness disconnects us from people. And I thought that that was really powerful. Have you thought about, I'm sure you have, but much about why sight is kind of the dominant sense and that people leave sound sort of, it's unappreciated, like you mentioned.
Yeah. Well, I think one of the reasons is because it's invisible and it's a very powerful force, like gravity, which is another very powerful invisible force that we don't think about, but it is there and it's is really important. And it's kind of interesting. I'm teaching um the course that was some of the inspiration for writing the book. And some of the students have been saying things like, boy, talk about underappreciated so often. And these are the audiology students that, they're saying people come um, to get a hearing aid and they find, indeed they have a significant hearing loss, and they aren't even there because they want to be there or think it was important to be there. They are there usually because someone is telling them, you should get your hearing tested. And so they go and they find that in fact they have a hearing loss. And how underappreciated is that? That sound is so very underappreciated, I think, by everyone, regardless of your hearing status. And I think also as our world becomes increasingly noisy, it is becoming more and more difficult to listen,
Mm,
because it's hard to listen when there is a lot of competing noise, right?
yeah, absolutely. Yeah, we were just talking about, I was just in Las Vegas for the the holidays and there was so much noise pollution. My brain needed a detox after that. Um, and yeah, there's a meditation I was just doing earlier this morning that's basically like listening to sound. So, you're trying to listen to what sounds are around you. And it's incredible to me how many sounds I have just completely tuned out, that they'll just kind of pop into my consciousness as I'm trying to attend. And I'm like, oh, there's that fan on, or my refrigerator is making a noise. And there's just so much around us that is pushed away. It's hard to, I suppose we do attend more to some sites than others, but I really feel like it's easy to forget that there's like this vibrant multicolored universe of sonic objects in motion around us, and it's just as varied and breathtaking as sight is. I really feel like Yeah, it's those moments where I'm paying attention, I can sort of glimpse that just a little bit.
Yeah. And also, I mean, you work with sound and sound engineering, and you realize how complex sound is. You know, so the first chapter really is about the ingredients in sound, and you know, sound in general is not appreciated or recognized, but the fact that it is broken down or can be broken down into many component parts that are important and to us for various reasons, again, is something that as we know more about sound and what it is made up of, we can appreciate how rich it is.
Your second subheading is sound connects us to the world. And it's, your book really kind of made this more apparent to me that, all of our senses, that's how we experience the world. But it's amazing that sound through these vibrations can help us relate to other people, relate to other things.
Yeah, no, I think that part of the reason that we feel disconnected, I think, as a society, is because we don't have as many opportunities to interact with each other sonically in a natural way. I mean, even now, you and I we're on Zoom, and we are losing many acoustic cues, and we're losing other cues as well. And I don't know that we realize what we're missing. We're gaining a lot of things. I mean, you and I couldn't be having this talk if we didn't have the technology to connect us that way. But if you and I were in person, I think the connection would be different.
Yeah, yeah. That makes me think of infants when they're born. The acoustic cues of their mother's voice, it's way more important than because they can't even really recognize a face when infants are born. Sight is not as important as acoustic cues, and the sound of the mother's voice, a caring voice, those frequencies create a trust, a bond between the infant and parent in a really powerful way. And it's kind of amazing to me that that would happen. You come into the world and there's an innate emotional connection to a sound.
But think about it biologically. Think about the fact that as an infant in the womb, the hearing system has already been developing and is functioning already
Mm.
by about 3 months of gestational age. And so the baby is picking up on vibration, which is in fact sound. It's sound through a different medium. It's not through air, it's through liquid, but it's still sound. And the fact that there have been wonderful experiments done by groups, especially in Barcelona. Esquerra is the lab where they have measured brand new infants' responses to sounds of parents, sounds of languages, sounds of music that the infant might or might not have heard during their gestation. And in fact, the brain will respond more strongly to the sound of the language that the baby was hearing in utero, and to known voices, and to music that they had been exposed to. So, with vision, in utero, there isn't really much that the infant is experiencing, but already for many months, the infant has been honing its vibrational and hearing sense.
Yeah, that's incredible. I think you make a point too in the book about how plants, they also are, you know, the sonic frequencies help guide the plants to what's important. So there's an experiment you mentioned about how someone had a pot that had two openings, and one was nearby to just a radio or something playing water sounds, and the plant roots were growing towards the sound, which is pretty incredible.
Yeah, I think that talk about underappreciated, the sense of hearing and vibration is underappreciated in humans, but it is unappreciated in other animals, and it is certainly, I think, underappreciated in plants. Yet any plumber can tell you that the roots of trees seem to make them their way to water pipes because they are being drawn to the particular frequencies of vibration. And it's not just any old vibration. It's interesting that, plants, as are people and other organisms, we are tuned to particular frequencies. And
Mm.
so the tree roots, for example, are tuned to frequencies around 100 or 200 hertz. And that is very much a dominant frequency for water running.
Wow. Are people also, this is just a random question, but are people, do they also have a resonant frequency? Like, are we more drawn to certain frequencies than others?
Well, I mean, our whole hearing system is one where, we are able to hear sounds roughly from a few hertz to 20,000 hertz. And you can think of that as a kind of tuning.
Mm.
A mouse can hear sounds at 40 kilohertz, which we can't hear. So they are tuned to these higher frequency sounds, and we are not. But the mouse may not be able to hear some of the lower frequencies that we can hear. So, that's a form of tuning.
This is something that you mentioned in the book. I think that like a cat is purring, starts to purr at a particular frequency to help their bones heal. Is there something like that going on
Perhaps.
in humans?
Yeah, it will not surprise me if there is, but I wouldn't know. I wouldn't be able to point you to particular research. What I can point you to in terms of tuning is if you think of plants. So one of my favorite examples is um, there are certain plants that, they depend on insects to spread their pollen around. And when the vibration of a particular kind of bee, say a bumblebee, when they sense that vibration of this particular bee, they will release their pollen to that bee because they know they're tuned to that frequency and they know that the bee is likely to then disseminate the seeds of that plant, and they aren't going to just release the seeds at random, but the plant itself, the plant is tuned to the frequency of vibrations of a certain species of bumblebee. So there's so much sensitivity to tuning and vibration that we're not aware of, and in plants and in other animals who are so much better than we humans are at picking up on various vibratory influences that are organized, because vibration is organized. It's
That's
not
it.
it's not just
Yeah.
random.
Yeah, I wanna play that plant, Flight of the Bumblebee. See if it opens up. You mentioned here that in the book that blindness, this is another point related to how hearing is underappreciated, but blindness was actually ranked by far the worst ailment amongst all of these terrible ailments. And then, it was like Alzheimer's, cancer, and deafness was like way down there. And yet, our hearing brain is intimately connected. It includes sensing, moving, thinking, and feeling, and it's also the fastest sense in the brain. So, in that way, it connects us in the most temporally proximate way, let's say, to the world. So, I think that's something to remember for anyone that gets fed that pull.
Yeah, I think that there's just so much about hearing and sound that is not common knowledge. And
Yeah,
so I'm hoping that, I was hoping through my book, and I'm hoping that you, with these interviews, that we can help make the idea of sound and its importance more recognized.
I hope so too. You mentioned in the book a few different examples of interesting sounds. I think you said from Bach to bacon sizzling, which is a great quote. But I could really smell the bacon, and I could hear it. When you just mentioned that, all of it seemed to be, so connected.
Yeah, well, I think what is under recognized is that the hearing brain is vast, and the hearing brain consists of, I say cognitive, sensory, motor, and reward systems, and our visceral systems. One of the things that we go through in the book is there's a lot, I'm not just saying this, there's a lot of biological evidence that points to the fact that sound is connected to our emotions and to our hormonal system. And we have a lot of data showing this in humans, in many animal models, even in plants. So there is this feeling emotional system. There is movement. I mean, sound itself is inherently, it's a movement. It's a movement of air molecules. And, to produce sound, you need to move. So the motor system is very, very, very much involved. So you have the emotion, the movement. With sound, we know that our senses commingle. And so we pull together information. Uh, we organize our visual and our somatosensory input together with the auditory. And that's another way in which the hearing brain is vast. It connects us to our other senses. You said before that you could smell the bacon. There are these true biological connections that support your experience. And I think something that is often really underappreciated even more is, we think about emotion, but we also there's our visceral system, our guts. At some point I mentioned an experiment where I don't know if you notice that when you're in an airplane, your sense of taste, your appetite is off. And that seems to be not because of the dryness of the air, but because of the sound,
Hmm.
because sound is our alarm sense. So again, it has to do with our emotion and our visceral sense, which connects to our fundamental appetite, how much salt you need to add to make something taste reasonable on an airplane, for example. Um,
That's why.
yeah, that's why. We don't really think about how, when you hear sounds, that our emotions are also, and our very visceral sense, for example, our appetite, who's hungry when there's this roar happening, when, evolutionarily, when there's an avalanche coming, who's thinking about food?
Hmm.
And so I just think it's very, very important to be thinking about how sound engages our visceral system, our emotional system, our motor system, how we combine our senses, and what we know, our cognitive senses. So
Yeah.
what we know influences how we hear the sounds. And so that, again, and we know, um, now finally it's becoming recognized that if you have a hearing loss, you are more likely to experience cognitive difficulties because your hearing brain engages that cognitive system, and if it is not being engaged because you have a hearing loss, it has pervasive effects
Hmm.
on on your thinking, on your memory, on your attention, your cognition. So the hearing brain is vast. And as a biologist, I've been able to, in this book, pull together biological evidence that we'll get into, I think, in more detail about how these different systems are all part of the hearing brain.
Hmm. It really reminds me of that's so powerful, and it reminds me of how I was watching a Blue Zone documentary recently, and they're talking about one of the reasons why people in Okinawa, they live, there's a bunch of centenarians, for example, and a lot of what they do during the day is, they have to walk upstairs. They're getting themselves up off the floor. There's all of these physical inputs that are, just sort of a part of their daily routine. And so without that physical movement that they're doing, their bodies would start to deteriorate. And so I think, in the same way, kind of on this point that biologically we are what we do, it makes sense, that if you have hearing loss and you're not getting those inputs, which connect so importantly to so many areas of thinking, that not just your hearing, but like those areas of thinking will degrade. I can even think of my grandpa passed away recently, but he had hearing loss for a long time, and I just remembered him never wanting to wear hearing aids and things like that. But yeah, it wasn't just that he couldn't hear, but even at the dinner table, that would prevent him from joining into conversation, which is an important input. It's like nutrition for your mind, right? To be part of those social situations.
Absolutely. Absolutely. And what we will get into, some of the core chapters initially on, chapters 3 and 4 is learning, and how making these sound to meaning connections is really important. And so how we spend our lives, you talk about the people who are spending their lives making certain movements and doing certain things. I mean, what we do very much affects who we are. And we can think about this biologically, and we can think of it with respect to sound.
Well, that connects to your next subheading, which is that the hearing brain, or the sound mind, is shaped by experience. So yeah, that's such a great framing of, our hearing brain grows based on our experience with sound. And then I guess, suppose just finishing up with the intro, the last subheading, sound mind. Again, people want to simplify and specify, maybe because it's kind of a discomfort when there's like more than one solution to a problem. Yeah, I liked that you didn't shy away from exploring, the role of context and how everything commingles, and how it's not just a simple black and white, this is how it is.
Yeah, I think that's important. And you probably also failed to get our Brainvolts newsletter in December. Sadly, and we're just kind of new to listservs. We have a very carefully curated list of people who are interested in, this kind of topic. And so every year, we send out a heartfelt newsletter, which I will send it to you. And also, in the interest, if you want to link it to this particular part of the lecture, at the beginning of the newsletter, I talk about, my students are asking me often, what is the answer to a question? And so often the answer is, it depends. And so the context, of course, really matters. And two things that I give an example of, two things that are opposed are in fact both true. And I think that being able to think that way is tremendously important as we think about a big topic like sound and hearing.
Yeah, absolutely. What's that Niels Bohr quote? Like the opposite of any simple truth is false, but the opposite of any great truth is also true, or something like that.
Right.
Yeah. So I wanted to move on to basically the first chapter, the first main chapter in the book, which again, in the sound mind relationship that we have, the two relationship, you're looking at the signals outside the head and then the signals inside the head, and then how they meet. And so this first chapter is all about the signals outside the head. So what is sound? And when I was reading these first two chapters, I really got the sense that, oh, I get why this is important, in a different way than learning about it in school.
The first chapter and the first couple of lectures is really about the acoustics of sound and the fact that it has, these ingredients that we don't think about. When you have a visual object, it has, color, shape, size, a weight, a mass, a texture, and that's very, very obvious to us. Right now, I'm feeling, this part of my pen, and it's cool, and so it's cool in a hot cold sense on my finger. But this is very apparent, whereas with sound there are also ingredients, but again you don't see them, but you are familiar with them. There is pitch, there is timing, and we know we're talking about timing on the order from microseconds to milliseconds to seconds to hours. Um, there is loudness, there is phase, there is frequency modulation and amplitude modulation. These are very important ingredients in sound that I think other very important ingredients are the fundamental frequency and the harmonics of sound. These are ingredients that impart, the many, many dimensions that exist in sound that I think if we understand them better, we can also understand how good a job your brain is doing at picking up these ingredients, and also where are the bottlenecks
Mm.
in terms of these different ingredients. But, really, even before we get to learning in beams, there is just a an acknowledgement of how sounds work, and the fact that sound waves are the movement of molecules that are moving. Not only we often use the analogy of a string, but in fact the molecules are moving in 3 dimensions, right? It's spherical. So these molecules are moving, but the wave itself is not moving. I talk about, the domino analogy, right?
Yeah.
Um, so I don't know if you want to kind of expand on that a little bit.
Yeah, that took me a little bit to get that point that, it's like knocking over dominoes. So another reason to buy the book is that there's amazing images in it. So you talk about how when a guitar string is plucked, for example, it's 14.7 psi local atmospheric pressure. So around us, it's like 14.7 pounds per square inch of pressure. And then when you pluck a guitar string, it changes to 14.7000003 psi. So there's this like very infinitesimal change in pressure, which then will change the pressure of the air molecules next to it. And that movement is what brings all the richness of, all of these things we think of, our friend's voice, bacon sizzling, like you mentioned, or, the sound of the ocean, just this, like these changes in pressure.
Yeah, and just think of an air molecule. So you've got this one air molecule, and it is moving. We often think, oh, well, this air molecule, as sound travels, the molecule itself is going to move down to the end of the football field. But in fact, it doesn't. It is the wave, the pressure wave. What this one molecule did is it caused movement in the molecules next to it, that then caused movement in the molecules next to that. And so you have this concatenation. But your first friend of a molecule is still here. It isn't, it hasn't traveled,
Right.
but the pressure wave has.
Right. You use a few different words to describe like different adjectives like whooshing, reedy, staticky, polyphonic, all of this rich vocabulary. It's interesting to me that it simply describes like different types of movement of the air, which is pretty incredible. I thought I was thinking about something you were mentioning in the beginning, in the visual analogy, there's color, there's shape, there's texture and size. And, in the same way, there's pitch, there's timing, harmonics, FM sweeps, things like that. But that, it is, even though that they are separated in that, like your brain isn't moving them up and down all at once, it handles them individually. Um, it's really the relationships between those that create the rich experience. Because in the visual analogy, it's not like there's anything in the real world like an abstracted shape, like a triangle that has no texture or size or color. So all of these things are distinct, but also uh, you know intimately connected.
It's a really good point.
And it is really important to separate them because as a speech therapist, all of the different phonemes, there are these tiny changes, like you're mentioning, a millisecond, microsecond changes in timing, for example, that can change a ba to a pa. So in the chapter, you go through the ingredients one by one. So there's pitch and frequency. And maybe it's an interesting point to mention that there's the perception and then there's the physical measure, right? So when you hear pitch, so something can be high pitched like a flute or a low pitched like a tuba, but the quantitative measure is frequency. So the number of events with respect to some fixed time period. And in this case, it's the number of air pressure vibrations. When you're talking about pitch, you mentioned voices, and you mentioned that voices, you're not really measuring the peaks and the valleys, but rather
The rate of vibration of the vocal folds is what you're talking about?
right. And I think that maybe it relates to the air when the glottis is opening and closing.
Yes.
So that's really what makes that's what we're hearing when we hear the pitch. Is that correct?
Right. And that's very kind of quite particular to speech,
Hmm.
because we're not talking about a string here. We're talking about an opening and closing of the vocal folds and the rate at which that happens. And a male voice, typically, this will be occurring at a slower rate than a child's voice, where the rate of the vocal fold vibration will be faster. And so it's because it's that relative, you can have the same signal. So we can both be saying happy birthday to you, but a child's voice is going to sound higher because of that rate of vibration. And we can call that rate of vibration, it's what I use to show the example of amplitude modulation, because
Okay.
um, uh, when you open and close the vocal folds, it's happening very, very quickly. So we can't even really, you can slow it way down and hear that it's actually loud, soft, loud off, that it's a pulse, if you will. And so that amplitude modulation is what gives the pitch of, your voice or your friend's voice. And and then of course on top of that, as a speech pathologist, you know about how that fundamental frequency or that opening and closing of the vocal folds, that amplitude modulation is going to be shaped by the position of your tongue and your lips and your mouth. So, but it's basically shaping this which is sort of the rate of vibration of any individual's vocal folds, which are going to, give you the impression of pitch.
Yeah. I'm getting transported back to grad school here. Um,
This is very complicated stuff. It's really complicated. And I don't know that it's necessary to really completely feel like you understand it as much as that you realize how many factors are really involved in an utterance, in sound.
yeah. And I heard that there's 72 different muscles that coordinate speech. And you really it's quite an amazing feat that you're pushing air through the system to shape these like very tiny differences in sound. Beatboxers are amazing at this. One of my friends is a world champion beatboxer, and he's showing me all these different tips and tricks. But I guess that brings us to the second subheading. So after pitch, we have the timbre or the harmonics. So timbre being the perception, and then the harmonics are the things that you can measure. And you could turn a vowel like an oo to an e by altering the harmonics. So the way that you shape your mouth and your lips and your tongue. But those harmonics are the things that you're altering when you're changing different speech sounds. On top of that, there's the timing aspect. When I learned about speech sounds in grad school, we didn't learn about it in this way. So that was another really cool thing, is that we learned about categorizing the sounds, so where they are in the mouth, and then the manner that you create them, so that manner and placement cues. But we never learned how it related to the physical sound wave, let's say. Like I had no idea that the FM sweep was the thing that would change a da to a ga, for example.
Yeah, I'm glad you made that connection, because I think that, the different fields don't usually do that. In speech and in speech pathology, you learn about the phonemes, and you learn what it takes to produce them and what they're called and the place and the manner of articulation. But you don't really think in those classes about what are the acoustics of the sound.
Yeah,
And so, in a class on sound, you might be thinking about, something like frequency modulation, but you really want to know, well, how is that connected with emotion in the mouth, for example, a da and a ga, that really is a motion change in terms of the articulators, but it's also a physical change in terms of the characteristics of the sound.
yeah. And it's just so fast. It's happening so quickly. That was another thing that you mentioned in the book that it's quite amazing to think about. A long time ago, they thought that these phonemes were kind of these distinct units. So they thought that they could take a stream of speech, and then they could take that waveform and then cut everything up such that you could pull out all of the different phonemes and then re-put them together in different ways and make words out of them that made sense. But it turns out that you cannot do that because, like we've been mentioning this whole time, that everything's this dynamic flowing process. And in actual connected speech, they call it, the phonemes sort of blend into each other in unexpected ways. And it's our sound mind that is tasked with the job of creating sense out of this dynamically very complicated speech stream, which is not as clean as we'd like to think it is.
Yeah, yeah, very much. And so it's physically called co-articulation, because there is so much articulation that's happening simultaneously that is going to also then influence the characteristic of the sound wave.
Yeah. And another point about, the fact that all of our senses are kind of mixing. They have this thing called the McGurk effect, where if you look at someone, I forget what the sounds are, maybe it's like a pa or a ga or a da, one of the syllables, and you have a face that you're watching that's saying a different sound, you will hear that different sound that person is saying. So we really are integrating these physical cues. And I heard that they have even done an experiment where they were trying to, it was like a noisy bar kind of setting, and they're trying to decide if this person had said a ba or a pa connected to some word that was meaningful in context. And they used the cue of a candle being pushed to decide which phoneme they're using. So we're really using these highly complicated inferences to decide what the sounds are. I guess finishing it up, kind of the transition into the next chapter, which would be looking more at the signals inside the head. So you mentioned that there's these acoustic signals, you know, outside the head, which become bioelectric signals inside the head.
Yeah. Yeah, no, that's exactly right. And what I think is helpful is that we can think about the signals inside the head in terms of the ingredients that we are thinking about with the signals outside the head. So we can think, how do neurons code pitch and frequency and phase and loudness? But it's really these same ingredients that the nervous system has to make sense of, but now it's doing it in a different language. It's doing it in the language of electricity instead of the language of sound waves.
Yeah, that's really exciting. And yeah, so much more to look forward to. Yeah, are there any other final thoughts on the intro in chapter one
No, I
that you
think
think
you've
you're
covered it. I think you've covered it. And I think that if people are both listening to the lecture and kind of going through, reading the book, it will be a very good, the podcast should be a good companion to the book and vice versa. So hopefully they will reciprocally inform each other.
yeah, just to encourage everyone again to buy the book and to support Nina. It's also been translated, I heard, into various languages, including Italian and Japanese, which I'm gonna get a copy. Going to Japan in May, so I'm gonna find it. But yeah, thank you everybody for listening. Thanks
Okay.
for your time.
Well, thanks, Garrett.